Hello students, I'm Dr. Z, and many of you may remember me from working with you in the second grade. I've been doing that for about 5 years. This morning I'm going to demonstrate how an electromagnet works. That's important because electromagnets are everywhere in our lives, in our homes. Electromagnets are in washing machines, dryers, computers, cell phones, televisions. They're in our cars. They're just everywhere. So let's recall our studies about magnets. And you remember there were kind of two basic kinds of magnets. A permanent one, this is a neodymium magnet. It's a very strong magnet. Bought this at Amazon. A permanent magnet will always be a magnet. On the other hand, there's another type called a temporary magnet. And let me demonstrate that. I have an iron nail here, and you know that iron is one of the metals that are attracted to a magnet. And if I take a paper clip, you can see now that the paper clip, which is also made of iron, is now attracted to the iron. So the magnetic properties now have become associated with that iron nail. I can even add a few more there, okay? But as soon as I take the nail off of the permanent magnet, the paper clips are going to fall off, and as you can see, the nail is no longer a magnet. So this is an example of a temporary magnet. We can make it and make it to have magnetic properties by exposing it, putting it in contact with a permanent magnet. Now there's a very special type of temporary magnets called electromagnets. And I'd like to demonstrate one for you, kind of interesting. What I have here is an iron nail, okay? Again, we know that iron nails are attracted to magnets. I have a copper wire that I wound around the nail, and I did that maybe 100 times. I rolled it around the nail about 100 times. And then the ends of the wire, one at the bottom and one at the top, I connected the ends of those wires to a little box here with 2 batteries in it and a switch, so that I can switch the electricity on and I can switch the electricity off. Okay, so when I turn this on, electricity is going to flow from the battery through all of those coils of copper wire and then out here and then back into the battery, so that I have now a flow of electricity from the batteries into the coil and out again. Now, remember that this is just an iron nail, and it itself is not a magnet, okay? You can see that this paper clip, which is iron, and this is usually attracted to magnets, it's not at all attracted to this nail. Let's see what happens when I turn it on. So the electricity now is running through that coil, and guess what? Whoops. It's now a magnet. You can see the paper clip is sticking to the copper wire wound around the nail. When I turn this off, the paper clip falls off. Let's try that again. No attraction. I turn it on. It's now, whoops. It's now attracted. It's become a magnet. The nail has become a magnet. And the copper wire, and I turn it off, and it's no longer. So that's the idea behind an electromagnet. You can turn them on and you can turn them off. And this is all working because whenever electricity runs through a wire, whenever you have electric current, it generates its own magnetic field. So that's why when the electricity ran through here, it imparted an electric field or a magnetic field into that nail, and that's why it became a magnet. Okay guys, thanks for your attention, and hopefully I'll see you next week and we'll do something even more exciting. I hope you enjoy and are excited about science as I am. Take care.